Hey guys, Elmer the Exponential Elephant here, and today we're going to be talking about exponential growth and decay. But here's a question first. Why don't elephants like playing cards in the jungle? Because of all the cheetahs!
First thing we're going to do is review exponential functions. So an exponential function is a function of the form y equals a times b to the x minus h plus k, where a is not equal to 0, b is greater than 0, b is not equal to 1, and x, h, and k are real numbers. So here we have some examples of graphs of exponential functions. Here you can see exponential growth versus exponential decay, a reflection over the x-axis, a reflection over the y-axis, vertical translations. Remember, we did all that last section. Exponential growth we talked about is growth whose rate becomes ever more rapid in proportion to the growing total number or size. This occurs when your a value is greater than 0 and your b value is greater than 1. So the number that is being raised to your exponent, that's a variable, that number needs to be greater than 1. That will cause exponential growth, like this orange graph. And exponential decay will occur when your b value is between 0 and 1 and your a value has to be greater than 0. And that's where there's a decline whose rate becomes ever more rapid in proportion to the growing total number or size. Transformations, we talked about this last time. Your a value controls whether your graph is reflected over the x-axis or not. So if it's positive, it's normal. If it's negative, then it's reflected over the x-axis. If your a value is greater than 1 or less than -1, that means it's going to be a vertical stretch, which means your graph is going to go up really steeply or down very steep. Your graph is going to have a vertical compression if your a value is between -1 and 1. So if it's a fraction between -1 and 1, then it's going to be flattened out. It's going to be way less steep. Your h value determines whether you shift the graph to the left or right. Your k value determines whether you shift the graph up or down, and your b value determines whether the graph is exponential growth or decay, just like we talked about. When b is greater than 1 and it causes exponential growth, your b value is going to be called your growth factor. Okay, when b is between 0 and 1 and causes exponential decay, it's going to be called a decay factor, just so you know that for today. Now, the compound interest formula is something we're going to be talking about today. In the compound interest formula, A is your balance, the resulting amount, whatever you end up with. Your P value right here is your principal. That's your starting amount. Whatever you start with, that's your P, your principal. Your R is your rate. That's going to be whatever percent you're increasing or decreasing by divided by 100. So if your percent is 5%, then your R would be 0.05. If your percent is 10%, then your R would be 0.10. Now your n is going to be the number of intervals, how many times the interest is compounded per year. So in a problem, it could say your interest is compounded annually, which means once a year, which means your n is just going to be 1. It could say biannually, which means your interest is compounded 2 times per year, or quarterly, which means it's compounded 4 times per year. In that case, you would put 4 for your n. If it was biannually, you would put 2. If it's annually, you put 1. So that's what n is. T, time in years, that's easy. Just plug in however many years, you plug that in for T. Lastly, please note, if the principal is decreasing at a given rate, you're going to change this plus in here to a minus. So please read the question carefully. Make sure you know whether the principal is increasing or decreasing. If it's increasing by a certain percentage, then it's going to be a plus. If it's decreasing by a certain percentage, this is going to be a minus.
What did the grape say when the elephant stepped on him? Nothing. He just let out a little whine. Example time.
Okay, example 1 says state the initial amount and the growth or decay factor of each function. If you've been staying with me and taking the notes, this is going to be super easy. We have y is equal to 38 times 5 to the x. Your initial amount is your a value. So if we think about this as y equals a times b to the x minus h plus k, your a value is your initial amount and your b value is your growth or decay factor. So in this case, your initial amount would be 38. Your growth or decay factor, in this case it would be a growth factor because it's greater than 1. So your growth factor would be 5, and then you're done. Here, y equals 10 times 0.5 to the x power. Now, again, your initial amount is your a value, so that would be 10 in this case. Is it a growth or decay factor? Well, your b value is 0.5. That is between 0 and 1, which means it's going to be a decay factor because this would be a graph of exponential decay. So this would be a decay factor of 0.5. Here, your initial amount is your a value, so that would be 5,000 in this case. And then your b value, the question is this between 0 and 1 or greater than 1? Well, 5/6 is between 0 and 1. Therefore, this is going to be exponential decay, so it would have a decay factor of 5/6. And then lastly, we have y is equal to 0.3 times 20 to the x power. Your initial amount is the number multiplied out front. That's your 0.3. And then is it growth or decay? Well, your b value is 20. That's clearly greater than 1. So that's going to be exponential growth. So it's going to be a growth factor of 20.
How do you raise a baby elephant? With a forklift! You try.
Okay, doing the same thing here. Pretty easy. Your initial amount is the number multiplied out front. So in this case, that would be 200. Now we got to figure out growth or decay factor. Well, this number right here being raised to your exponent, that is less than 1, but greater than 0. So it's between 0 and 1. That means it's going to be exponential decay. So this would be a decay factor of 0.9. Here, your initial amount, the number multiplied out front, is 1,500. Your growth or decay factor is this b value here. Is that greater than 1? Yeah, just barely, but it is. So it's going to be exponential growth. So it's going to be a growth factor of 1.01. Here, 0.2 is going to be your initial amount because that's the number multiplied out front. And this, trying to trick you, is this a growth factor or a decay factor? Well, this number is actually greater than 1. Right? 7/5 is greater than 1. Therefore, it's going to be a growth factor of 7/5 because it's greater than 1. And then here, 25 times 0.75 to the x power 25, this number multiplied out front is going to be your initial amount, 0.75. Because that number is between 0 and 1, this graph is going to have exponential decay. Therefore, this is going to be a decay factor of 0.75. Now, example 2 says find the balance in each account after the given period. So we have a certain dollar amount and it's earning a percent interest that is compounded annually. Okay, that means we're going to use the compound interest formula. There we go. Now, we just got to plug in what we know. $12,000 principal, that goes in for B. Easy. 4.8% interest. 4.8 does not go in here. What goes in here is 4.8 divided by 100 because we take the percent and divide it by 100. We end up getting 0.048. That's going to go in here. It's compounded annually. That means once a year. So we plug in 1 for N, and then after 7 years, 7 goes in for T. Sweet. Now, in order to evaluate this, we start with our parentheses, right? We got to do order of operations. So we simplify this. What's 0.048 divided by 1? That's 0.048. Add that to 1. Boom. Next, order of operations, we do exponents. We're going to do this, raise it to the 7th power, and then multiply that by 12,000. We end up getting this number right here. Now, since we're talking about money, we need to round to the nearest cent. So we take it and round it to the 100th place. So this becomes, the balance is approximately $16,661.35. Same thing here. We're going to use our compound interest formula. We have a $20,000 principal that goes in here, earning 3.5% interest. So 0.035 is going to go in for our R. It's compounded monthly. How many months are there? 12. So we plug in a 12 for these ends here and here. And then after 10 years, that goes in here. Sweet. Now, order of operations. To simplify this, we start with 0.035 divided by 12 because we got to do our parentheses first. So we do that, then add 1. The 12 and the 10 multiply to 120. We then take this number, raise it to the 120th power, and multiply it by 20,000. We end up getting this number right here. Now that I have this, I'm going to round it to the nearest 100th. So the number after this is a 6. So this actually rounds up, which rounds this up. So we end up getting our balance is approximately $28,366.90.
Did you know elephants can grow up to 11 feet? Most only have 4 though. You try.
Okay, doing the same thing. So here we have our principal is $5,000. So that's going to go in for our P here. Our principal is earning 1.5% interest. So to write that as decimal, we divide it by 100, we get 0.015. That goes in for R. It's compounded quarterly. So in for N, we're going to plug in 4. That's 4 times a year. That's what quarterly means. And then after 3 years, so we're going to plug in 3 for T. We then simplify using order of operations. In here, we take 0.015 divided by 4, then add 1. Then we take that, raise it to this 12th power over here. Then we're going to take that result, multiply it by 5,000, and we end up getting our answer. Now to round this to the nearest cent, we have to round this 9 up because after it there's a 9, so we round that up, which makes this round up, so it becomes 0.70. So we end up getting $5,229.70. Here, same thing. We take 3,500, plug it in for our P, that's our principal. We take 6.75, write that as a decimal. We divide that by 100 and we end up getting 0.0675. That goes in for R. It's compounded monthly again, so we write 12 in for our N, and it's only compounded monthly after 6 months. Interesting. So it's still a 12 that we put for our N because that's the number of intervals, but for our T, since it's in years, what we're going to write 6 months is half a year. So in for T, we're going to put 0.5 or 1/2. Now, what we're going to do is we're going to simplify this. So we simplify inside here first. Then we're going to take whatever this is. We're going to raise it to the 6th power because that's what 12 times 0.5 is. And then we're going to take that and multiply it by 20,000. Again, for all of this, you're going to need to use your calculator. So make sure you do. We're going to round this guy up right here. So again, after this 9, there's an 8. So to round that up, that makes this round up as well. So our balance is going to be approximately $3,619.80. Now, a word problem says the population of a city is 45,000 and decreases 2% each year. If the trend continues, what will the population be after 15 years? So step 1 in a word problem, we're not scared. We can do this. Step 2, what is it asking? It's asking what will the population be after 15 years? Okay, so what we're going to use is our interest formula. So it looks like this. Now, what we can do here is we can plug in what we know. What do we know? We know that the population of the city is 45,000 in the beginning. So that's our starting amount. That's our principal amount. So that's what we're going to put in for P, 45,000. It decreases 2% each year. So 2% we're going to write as a decimal. So we divide that by 100, we get 0.02. That's going to go in for our R. It says if the trend continues, what will the population be after 15 years? So we're going to put 15 in for T. Now the only thing we don't know is our N. Well, because it doesn't give you a certain number of intervals within the given year, it's just going to be 1. So you're just going to plug in a 1 for N because you're just doing it once a year. It decreases 2% each year, not biannually or quarterly. So you just put a 1 in for the N. Now, the only problem here is that it decreases 2%. It doesn't increase. So we have to change this plus to a minus. Now we can plug in everything. So we plug in our 45,000 for our P, our 0.02 for our R, our 1 for N, and 15 for our T. Sweet. Now we simplify. In here, 0.02 divided by 1 is still 0.02. Then you do 1 minus 0.02, which ends up giving you 0.98. We then raise that to the 15th power and multiply that by 45,000. We get our population. So what we're going to do here is we're going to actually round this to the nearest person because you can't have 0.6 of a person. So we say the population will be approximately 33,236 people.
Where do you find elephants? Depends where you left them. You try.
Okay, so this one says your family buys you a car for $20,000. The value of the car decreases about 20% each year. After 6 years, you decide to sell your car. Someone calls you with an offer of $4,000. Should you take it? Explain. Okay, so we're doing the same thing here. It's a word problem, so we're not scared. We can do this. We also need to figure out what is it asking us. It's asking us, should we take the $4,000? And we need to explain. Okay, let's figure out how much this value of the car decreases. In order to do this, we need our equation. Here it is. Now, our principal, that would be this $20,000 that we start with. Sweet. It also says the value of the car decreases about 20% each year. So 20%, that has to go in for the R, but we have to write that as a decimal, so it's going to be 0.2. So we put 0.2 in for our R, and it says each year. It doesn't say like twice a year it decreases, so we just put a 1 in for our N. And then after 6 years is how long we're deciding to sell our car. So 6 is what we're going to put in for our T. Now the big thing here is, notice it says the value of the car decreases about 20% each year, which means this in here has to be a minus sign because instead of an increasing rate, we want a decreasing rate. So we do 1 minus our rate. So we change that to a minus sign. Now we plug in everything. So 20,000 in for P, 0.2 in for our R, 1 goes in for our N, and 6 goes in for our T. We then simplify. 0.2 divided by 1 is 0.2. 1 minus 0.2 is going to be 0.8. Then we do 0.8. We raise that to the 6th power by our order of operations. We've got to do exponents before we multiply. So 0.8 to the 6th multiplied to our 20,000 gives us 5,242.88. What does this mean? What is this telling us? Well, this is saying that according to how much the car depreciates over our given number of years, so 20% each year, this $20,000 car is now worth $5,242.88. but someone is offering you $4,000 for it. Well, that seems like they're lowballing you, right? So you should not take the $4,000 because your car is actually worth approximately $5,242.88, okay?